All right, so let's look at probability now. What is probability? What is it all about? Okay, let's have a look and see if we can make sure we understand all this. So, probability is the measure that the chance of something happening. All right, so in numbers, we want to calculate. It measures the outcome of an event and how likely, in particularly, how likely that outcome or that result of an event will happen. An event, remember, is some kind of measurable test and observation. Let's look at the word event, what the word event means. All right. So we got the word an event. An event is almost like something that's happening. It's some kind of observation. And sometimes we also use the word trial. So just a bit of terminology over here, right? Trial. And then probability, the word itself, probability almost sounds like probably, but probability is the chance that something happens. All right, the chance that something happens. And then we've got outcome. Outcome is almost like the result of something. So these are the common terminology um, use at the moment whenever you are dealing with it. All right, then we have the concept of mutually exclusive. And mutually exclusive results are the exact opposites of each other. Either one or the other has to happen. All right. So the use of not helps with mutually exclusive events. The opposite of rainy is best thought of as not rainy, rather than vague terms such as fine. Another formal term seen sometimes is complement. All right, when something doesn't happen. So event A would take place, but then you'd have the complement that it would not take place. Right, so it would take place, and these are events, and we call that the complement. Right, complement spelled like that. And what we also notice is that the probability of an event happening plus the probability of it not happening always equals to 1. All right, so we just kind of going through all kinds of ideas around this. The probability can only be of any number. It's always ranging between 0 and 1. And that means over here, this is the probability that it would happen at 1 would be certain. And then if it's 0, it means that it would be impossible. And so halfway would be 0.5. And if you are somewhere over here, it would be highly likely that something would happen. And over here, you'd have highly unlikely if it's close to 0. And these are percentages as well. So 1 can be seen as 100%, 0 can be seen as 0%, 0.5 is 50%, highly likely is like 80%, 20% highly unlikely that something will happen. Okay. So they can be also written as decimals. I mean, this can be 0, 0.2, 0.5, 0.8, and 1. All this. A probability of 0.2 means very little. All right. So highly unlikely. And probability of 8 means highly likely. So the word likely is used. Unlikely and likely. Remember that no probability can ever be bigger than 1. It doesn't exist. If you have a probability of some event which is greater than 1, that would be false. That does not exist. Okay? So remember, your probability is a fraction, a percentage, or a decimal. Let's look at the next part now. Experimental probability. What is experimental probability? Well, probabilities can be calculated experimentally when you have a certain number of trials or events. And so when you calculate the probability, it's equal to the total number of successes divided by the total number of trials. Experimental probability is only an estimate, and it will change slightly each time it is measured. When calculating experimental probability, we ideally test the entire population, which is called the census, to get an exact result. Now, often a census is not possible because it might be too difficult or too expensive, or the population is infinite. In many cases, we take a sample and work from that. The sample needs to be random, so we would have some kind of population, and we would take a sample out of that population and we test that sample. So when you look at the population, let's say this is New Zealand, and over here I take a sample from Auckland, you can see it's found inside New Zealand. The sample is a part of that. All right. This particular sample is biased. And why? Because it's not taken into account the rest of the population. However, if I did change the sample into something different, something like this, where I would take it to different parts of the population, it doesn't have to be New Zealand, it can be anything. All right, it can be a school where I'm taking students' data from different parts of different classes of different grades, so that there's some kind of evenly spread of randomness. And random, the word random allows us to be unbiased, not cheating. All right, bias means that it's almost unfair, like a biased coin. Like you toss a coin, but let's say it's slightly weighted on one side and continuously lands on tails. That's biased. So unbiased means that it's considered fair. It's a theoretical property that we apply, and it may also be in real. Okay, so we would put some kind of assumption in place to say something is unbiased and this is random, and therefore based on that we can create some kind of experiment that would be fair. We want to create a fair outcome. All right. Then there's the word independent. Independent is when the outcome of some kind of trial does not affect the result of the others. Okay. So the outcome of one trial does not affect the others. An example of this would be like rolling a dice. Right. So if you roll a dice, every time you roll a dice, you got to pick it up. So the numbers have got to change. They're not linked to each other. They're not attached to each other. The result of the next roll is not going to be affected by the previous roll. And so, with that said, we would end up with that. All right. Let's have a look at some examples of calculating simple theoretical probability. Okay. Let's suppose I have a circle. Let's draw a circle in here. Okay, I'm going to draw a circle and I'm going to divide it into different parts. Okay, so I'm going to divide it into different parts here. And let's say we color code these. Okay, we're going to color code these. It'll take a second. So let's say I've got red over here, I've got red over here, and each of these are equal. Okay, I might need to put another line in there just to connect that up there. And so that would be that. Okay, so I was going to make it color coded. So let's change this color to green. Let's make this one blue. And we make this one purple. Okay. And I've got some kind of spinner. All right, I've got a spinner in place. So some kind of random spinner like this. And it's spinning. And it can land anywhere on any one of these colors. Okay. So now I want to calculate what is, and me saying that each of these are equal. Okay, so each of these are equal segments or sectors of the circle. What is the probability that we would land on red? So the first thing we have to remember is count how many reds do we have. We have 2 reds. So we take 2 reds over there and we divide it by the total number of sectors, and that's 1, 2, 3, 4, 5. And so that becomes 2 over 5, which can be expressed as 0.4, and it can also be 40%. And on our scale from 0 to 1, it would be close to even, where it's more unlikely that it would happen, right? So that's going to be impossible, remember? And this was certain. So this is going to be unlikely. So that's an example of that, right? If I have to calculate the probability now of landing on purple, for example, purple is going to be 1 out of 5, and that actually 0.2, which is 20%. And 20% is over there. And that's highly unlikely that that would happen. And you can see it's 1 out of 5 and versus 2 out of 5. So only if it was 3 out of 5 would it be 60%, and only then will it be 60% from there. And that would be likely. Let's have a look at another example. We roll 2 dice. Okay, so roll 2 die. Okay, dices, 2 dice, and we create what is known as a two-way chart. Okay, a two-way table. A two-way table looks like this. Table of outcome of events. On the left-hand side, we put the outcomes. So it'll look like this. 2 dice you're gonna have 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. And so when you roll each dice, so you got dice 1 going this way, dice 2 going this way, and you add it up. This is going to be 2, this is going to be 3, this is going to be 4, 5, 6, and 7. This is going to be 3 because 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, and wherever they meet up. So we're taking that 2 and that 4, and we're saying 2 plus 4 is 6. That's how we would get to 6. What you notice is that it's starting here 4, 5, 6, 7, 8, 9, and then 5, 6, 7, 8, 9, 10, and then 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, and 12. And so from here, we can see that the probability of finding, for example, let's say we want to find what's the probability that if I roll 2 dice, I will get a sum of 5. Well, that would be 1, 2, 3, 4. 4 possibilities out of total 6 times 6, 36 outcomes, which comes to 1 out of, divided by 4, 1 out of 9. And we could leave it like that. We could put it in a calculator and get a percentage as well. And this is a sum. Remember, each of these is sums, so the probability of sum of 5. Another question, random question. Let's say you want to find the probability that you get a prime number, a sum that is prime. Well, you have to know your prime numbers. What are your prime numbers? Prime numbers are 2, 3, 5, 7, 9, nope, 10, nope, 11. All right. So in that case, you'd count each one of those. So this is another example. It would be 3 of those. And we're counting this as well. 3 plus 4 is 7. 8, 9, 10, 11, 12, 13. And then 14, 15 out of 36. We then divide by 3, we get 5. Divided by 3, we get 12. And then we're done. Okay, and that would be the probability in a two-way table, for example. Okay. So just a brief example of that. We could also look at another one, a deck of cards. Many people don't actually know how to play cards. Well, whenever you deal with a deck of cards, what you have to remember is that there are 52 cards in the deck. in total. It's made out of 4 suits. All right. You can either get hearts, you can get diamonds, you can get spades, or clubs. Some people call clubs flowers. Hearts starts from, let's say, ace, and it becomes 1, 2, 3, 4, 5 until you get to 10. Then jack, queen, and king. These are known as face cards or picture cards. And you have exactly the same for each of these suits. We have 13 of each of these as well. And so, for example, they ask you the probability of choosing an ace, choosing ace, any ace. Well, we have 1, 2, 3, 4 aces over here. And we have a total of 52 cards. So the probability will be 4 out of 52, which would be divided by 4, 1 out of 13. And that would be the probability of that. Another example would be, let's say you want to find the probability of choosing a face card. All right. And that would be these over here. And you'd have 3 in each suit. And if we count this, I mean, you get 3, 6, 9, 12 out of 52. That becomes 12 divided by 2 is 6. 52 divided by 2 is 26. I mean, 12 divided by 4 is 3. 52 divided by 4 is 13. And so that's 3 out of 13. The probability that you choose a king of hearts. Well, there's only one of those over there. So that one would simply just be 1 over 52. And we're done there. All right, so that's just a quick introduction on that. We have our two-way tables. We have our sectors where we're flipping, or you can also call it a spinner. Okay, and that thing spins, and we find the probability. All right, the other one is we can also have a bag of different colored balls and then choose from there as well. So the concept of probability brought to you in one go. All right, and the idea of experimental probability as well.